Hello, Mr. Taylor here. One more time. Now we want to take a look at Module 11.2, Example 2. Again, we are working with equations with variables on both sides. And now we want to jump into solving an equation that involves decimals. So we've looked at them involving fractions, which is another form of rational numbers, just like decimals is a form of rational numbers. And we saw where we literally found the least common denominator and multiplied and turned these fractions into integers, and it was easier to work them. So we can do the same thing with decimals. We just have to take a look at the place value and determine from each decimal which place value we're going to move it. We want to always move it to the highest place value, so we turn every single decimal. And then we're looking at it from the power of 10. Anyway, let's get right on into it. Our learning objective is students will solve equation with decimal coefficients and constants. Again, keep in mind this rational number, key vocabulary, which is a number that can be expressed as a ratio of two integers, or a decimal that terminates, which means it has a remainder of 0 when you divide, or a decimal that has a repeating pattern. Well, according to the book, solving an equation that involves decimals, when you solve an equation with variables on both sides that involve decimals, it is the same, or should I say similar, to solving an equation with fractions. But instead of multiplying both sides by the least common multiple, you multiply by a power of 10 to eliminate the decimals. I'm telling you guys, this is really going to be pretty easy for you. You're going to really love this. So Javier walks from his house to a zoo at a constant rate. After walking 75 hundredths of a mile, or 0.75, however you want to read that, he meets his brother Raul, and they continue walking at the same constant rate. When they arrive at the zoo, Javier has walked for 0.5 hour, and Raul has walked for 0.2 hours. What is the rate in miles per hour at which the brothers walked to the zoo? Okay, let's go ahead and take a look at breaking this problem down, getting the algebraic expressions out so we can create the equation. Okay, step 1, it says write an equation from the distance from the brother's house to the zoo, using the fact that the distance equal rate times time. So let R equal the brother's walking rate. So here we go. It says distance to the zoo would be 0.2R plus 0.75 equals distance, which is from where they met and walked, 0.5. So we have to make sure that we understanding what part here that they're talking about. So let's go back, take a look. It says that Javier walks from his house to the zoo at a constant rate. After walking 3/4 of a mile, 0.75 miles, he met his brother. So he went from his house, let's just say point house, he went 0.75 miles before he met his brother. Still hadn't gotten to the zoo. And then when he met his brother, they continued walking at a same constant rate when they arrived at the zoo. And it said Javier has walked for 0.5 hours and Raul has walked for 0.2 hours. So you have to think about now then how far has Raul and Javier had walked. So we see that point. So let's go back and see what they're talking. So it says now the distance to the zoo is 0.5. Where do you think the 0.5 came from? When we go back and look, and it says Javier has walked, when they arrived at the zoo, Javier has walked for 0.5 hour and Raul has walked for 0.2. So again, that other distance is 0.5. Okay? Now, we have distance to the zoo, distance to the zoo. So we look at the expressions that they give us. 0.2r plus 0.75r is equal to 0.5r. Now, taking a look at these decimals, tenths, hundredths, tenths. So that means I'm going to multiply by 100. Again, tenths, hundredths, tenths. So hundredths would be my largest place, so I'm going to multiply everything by all three decimals by 100. So here, 100 times 0.2, that means just adding the two zeros and moving the decimal, I get 20. And here, 0.75 times 100, adding the two zeros, moving the decimal, I get 75. And here, 0.5 times 100, adding the two zeros, move the decimal, and I get 50. So my new equation, without those troublesome decimals, I don't mean to say that they're not easy to solve. It's simply 20r plus 75 is equal to 50r. So now, simple equation, we want to use inverse operations to bring our like terms together, putting the variables on one side, constants on the other side. We should be very familiar with this by now. So here I'm looking at my r's, my variable term 20r and 50r. 20 is the smallest, so we're not going to make that mistake I made back in the problem earlier. We're going to subtract 20 from both sides. Okay, this will give me my 0 pair and bring down my 75. And here 20 from 50 give us 30. So my equation says 30r is equal to 75. And then since 30 is being multiplied, we want to divide by 30. That's going to give us 1r is equal to 2.5. Now I know you're probably wondering, well, hey, why do we get a decimal? But the answer didn't say we could not get a decimal. The answer simply says, what the problem is simply saying, let's make it easier to come to our answers. So the brother's constant rate of speed was 2.5 miles per hour. Okay. Still, not so difficult. Just make sure you understand. Take good notes here. Now, what I want you to do is take a look at this problem. Logan has two aquariums. One aquarium contains 1.3 cubic feet of water. The other contains 1.9 cubic feet of water. The water in the larger aquarium, you got to determine which one of the two is the larger, weighs 37.44 pounds more than the water in the smaller aquarium. So it's not saying that's what it weighs. It says it weighs that amount more than that smallest amount. So you want to write an equation, which means write two expressions, combine them as an equation with variables on both sides to represent this situation, and then find the weight of 1 cubic feet of water. Okay. Well, here we go. What are they asking us to do with this? Well, if I look correctly, I see that one aquarium contains 1.3 cubic feet and the other one 1.9. Well, the 1.9 is the larger amount. So if I use X for my variable, I'm looking at 1.9x is equal to, since that's the larger, 1.3x plus 37.44. It's just like the very first problem, the problem that we just did. What we're looking at is this 1.9. This is hundredths. Tenths, but 0.44 is hundredths. So we want to multiply each single term by 100. So that'll give me 100 times 1.9x is equal to 100 times 1.3x plus 100 times 37.44. Okay. So let's take a look. If I multiply 1.9 times 100, so I know I'm going to have 100, and 0.9 of 100 is 190x is equal to, same thing here, 1 times 100 is 100, and 0.3 will give me 30, so that's going to be 130x plus, and if I just multiply this times 100, mean I'm moving my decimal places 2 places over, and I'm winding up with 3,744. Looking at my variable terms, I have 190x and 130x, so I want to bring the 130x to the left because it is smaller than the 190. I don't want a negative coefficient, so I'm going to subtract 130x from both sides. Okay, that's going to give me a 0 a pair. Over here on the left side, I see 130 from 190 is 60x, and that's going to equal to my 3,744. Since I'm multiplying x by 60, I'm just simply going to divide by 60 both terms, and I'll have x is equal to 62.4 pounds. I'm going to make that look like a pound. Okay. I really like that. That is, I think, something that you guys can take and use. Just go through, work some more problems, get a full understanding. Got any questions? Please let me know.